I'd say that the background of this is, for the most part, this conference is really about people that are directly working on projects in rural Alaska to have the opportunity to share lessons with one another. And one of the things that we've generally done is we've tried to shy a little bit away from vendors presenting in many of the panels, because we're really not wanting a sales pitch. We don't really want to hear about a product. We want to hear about the process, about projects, about what's working, what's not. That's what we're looking at in general with the Rural Energy Conference. But on the other hand, we also know there's all kinds of things that are going out there. It is really difficult to find time to talk about all the really exciting things that are happening. We've reduced the number of sessions, concurrent sessions, from 4 to 3 this year, which means that there's even less time for people to present information on what they're doing and what they're involved in. So this is an opportunity for people to really talk about what's going on that they're excited about that we did not get on the agenda this year for the conference. And also for, if there are vendors here that have an exciting product that they think people would benefit from hearing a little bit about, this is your chance. 3 minutes. And we're serious about that. This isn't where we're going to let you go over a little bit. We're so serious. All right, Marcia, do you want to give an example of our bomb? We have a bomb that we're gonna Marcia.
Well, I thought we'd wait and let you do a presentation so we can just make you the first victim. Why don't we start with the door prize?
Want to start with the door prize?
Yeah, and so if you're if you're one of our speed dating speakers, why don't you come over to this side of the room so you can be ready to have your shot at the mic? And I know Mark Hoffman, who's one of our sponsors, thank you, was queued up to be first. And if you have a PowerPoint slide, you don't get extra time, so you got to use your 3 minutes judiciously. If you want to draw a name out of that first bowl there, we'll give our first door prize away.
We will do that. First door prize, I'm going to let Mark draw it.
And then we'll do your history toast.
All right. Jackie Schaefer.
I knew it.
Where's Jackie?
I guess she's signed,
Is she
sealed,
here?
and delivered. I gave it to her already.
Oh, wait a minute. How did you do that?
I
thought that was my job.
Okay, so we're going to get started. We're queued up, ready to go. So our first amazing speaker, Mark, take it away.
You're actually
Marcia,
going to have to hold the timer.
Hold the timer till he actually gets the mic.
If you have a presentation, we're going to need you to be up at the podium here. Everybody else can just stand here on the floor if you feel more comfortable and take my mic. So,
I need your mic.
That one's not working?
Well, I was told I get to have the portable
really?
mic. Yeah.
This one should work.
There's no portable mic.
Do you want a portable one?
Yeah, I'm from New Jersey.
Okay, he has to move.
This presentation's not coming up.
10, 9.
Okay. So one of the things that I'm really thrilled about is to be invited here. I'm Mark Hoffman, CEO of Innova's Power. We make a variable speed generator that has significant savings in fuel efficiency. Unfortunately, this thing is advancing in a way I don't want it to. So anyway, I think I'm going to end up just talking to it and letting the thing flash through. One thing that I really like about being in Alaska is that I learned very quickly in my first meeting at AEA is people are very frank. If they think I'm lying, they're going to tell me that. I'm from New Jersey, so I'm used to that also, so I'd rather not read minds. The point is, I know you get many people up here telling you that they're going to save a tremendous amount of money, maybe 1 in 10 work. We believe will be that 1 in 10. So what we do in variable speed power generation, just like your car, we let the speed of the engine of your generator go up and down proportional to the power load. And by doing that, our maximum savings could be about 35% fuel. Average studies when we do remote communities in Alaska and Canada are between 10 and 20% because most of your communities have already done a lot of very efficient things. So we have to compare that to whatever baseline you're at. So the basic principle of a variable speed generator is as your power load goes down and up, like your car, the speed of the engine goes up and down. For those of you who don't know power generators, they don't do that. They run at 1,800 RPMs or 1,200 RPMs, and they live there no matter what your power loads are. And that creates a serious amount of problems when you're at low loads like wet stacking, and you become very inefficient and burn a ton of fuel when you're at low loads, which is very common. The other problem it creates is that you're just not able to take advantage of the full efficiency range that the engines were designed for. How we do that is we basically take that and put that through a power converter, and when we put power through a power converter at the end, out comes very nice clean power. One thing that's a very, very important benefit is microgrids. So one of the big benefits of microgrids is you can do plug and play with our system. You can plug in our product. You can run your generators down to 10% or even below and be more efficient than if your generators are running at 30%, where you have to get capped. And so by running at 10%, you really get the full realization of your renewables, your grid stays stable, and because of the way we designed our system, everything can just be plugged in and be able to manage very directly. So with that, I think my bomb's about to go off. Is that 12 seconds? Appreciate your time and your attention, and I think I have an extra 5 seconds and I won't use it. Thank you very much.
Well done, well done. So since you have to be present to win, we make sure everyone stays here. We have to save our fabulous prizes to the end. You want to draw us another name before Mr. Osman goes next?
Would you draw a name for us, please, sir? Thank you. No way.
Yes.
Come on.
Did you pick your name?
Look at this. He drew his own name. Okay.
Okay, so that just kind of leads
Okay,
us to...
I think that's fair.
That, you
It
know-
looked legitimate. He was looking at me. I don't know.
You know, that's one thing about Earl. He knows how to get things done. And so he could talk up for hours on a lot of things and talk about his company, but he's going to spend his 3 minutes talking about one thing. And so here's one of my favorite pioneers in the energy industry, Mr. Earl Osman.
Thank you. Right here?
Right here,
Can I
right.
start now?
You can go right now.
My name's Earl Osmond, and we started our project in 62 years ago. It was in a homestead, building a hydroelectric power plant, and we tried to put together a hydroelectric power plant, which we have now, and it's over a megawatt. It's generating power as we speak. We're selling power for 7 cents. In 10 years, it'll be 3 cents, and if you're interested in the plant, I'll send you information. Take the information that you get from this organization, and you can send me your card, and I'll send you some information. That's 3 minutes, isn't it?
Oh, you did. You still got, you
45 seconds.
You did great.
Do you have like a dance or something you could do?
One of the important things is we never could get any money, and AEA made it possible for us to finance it and do this project. We couldn't have done it without the money. We couldn't even get it from the guy that had the Clutna hydroelectric power plant and had all this money and everything, and we still couldn't get any money. Thank you.
All right, thank you, sir. All right, so while you're still up here, maybe this time you can pick somebody else's name, and that would be our next door prize. But 62 years getting the project done. The man is tenacious. Okay.
One, Earl.
Just one. Okay.
That's a nice.
John Haas.
John Haas. Where is Mr. Haas? I know he was right here just a minute ago. And Mr. John Fox ought to be getting queued up for...
All right.
If he doesn't show up in the next minute from being out and getting some drinks, then it's going to go back in the kitty.
We have another John next. John Fox. Does it work?
Should be.
Do you want to use this?
This one's not on.
Okay, my name is John Fox. I'm the CEO of Electrotherm. We do waste heat to power. Some people may be familiar with the green machine. Just came from a session, talked about the installation at Toke. This company's a lot different than that generation machine, and we're still working to resolve that situation. We have 42 machines worldwide now. We have 35, 65, and 110 kilowatt machines. Hot water is our fuel, so 180 degree water to 240 degree water is basically our input, and we make electricity from that. So you can see we have over 250,000 hours, which is about 28, 29 years of operation experience. So of the 42 sites that we've installed commercially, we've done stationary gensets. That's mostly 50% of our projects are stationary genset waste heat. We've done oil and gas, geothermal, steam condensate, biomass boilers, concentrated solar, etc. Being here for the last couple days, it seems like the diesel genset opportunity is, particularly the first opportunity, but then I think also potentially waste biomass streams, which I'll talk about. So the fleet that we have across the world, most of our people don't speak English. Czech, Romania, Austria, Slovakia, Italy. So the machine has to be easy to work on and easy to service. In about 2.5 days of training, 98% of the issues with the machine, from preventive maintenance to other maintenance issues, can be resolved. Anybody that works on a reciprocating engine can work on a green machine. It's a very simple piece of equipment. Here's the fleet hours as we cross the 250,000 hour mark. The pedigree of machine that's been deployed in Alaska, unfortunately, is way down on the chart here. And now the pedigree that I have for sale commercially is a Block 5 machine. It's literally 5 iterations of improvements, and that's how you learn with fleet hours, you learn with experience. We're still trying to work with AT&T and to get a new unit deployed and have it operating. We have 3 units going to Unalaska next week, which we're really excited about. So here's our economics. Off the waste heat, this is 20-year capital, O&M, and fuel. Fuel for us is 0. If you're making 30 kilowatts off our machine, it's 7-cent power. If you're making 60 kilowatts off of one of our machines, it's 4-cent power. And if you're making up to 100 kilowatts, depending on your waste heat stream, it could be as low as 3-cent power. One thing I want you to think about is if you are doing if you're doing new engines or radiator replacements, we can actually become the radiator for your system. You do not have to buy the OEM radiator, so we are a radiator with a payback. We've proven that with the military Department of Defense money. This engine and ORC combination are going to Guantanamo Bay in the fall. Various configurations, 35, 65, and 110 kilowatt. Here's the site in Unalaska. Our technician.
Okay, he's done. Get going.
Thank you.
Thanks, John, and we are looking very much forward to seeing how those units do in Alaska. So
thanks. You not let him pick the next?
Oh, he ran off so quick, All right, I think I'm going to do this one.
Okay. Yeah, he got bombed.
Ben Schenkman.
Here we go.
Sandia National Lab.
All right. Thank you. Okay, where's our next speaker? We got. I gotta say who it is. Where's Dina? There's Dina.
Okay, who's the one after that, just so that they're ready?
We'll have George.
George is up next.
Can I stand on the stage since I'm short?
You can do whatever you want. Absolutely. Yeah. This is your moment.
Okay, thanks. Hi, I'm just going to stand up here because I'm short, not that I have a presentation. So, am I starting up? Oh, my name is Dina Straight. I'm with Bettisworth North Architects and Planners. A lot of you know me from my former life at AHFC, where I was lucky enough to meet many of you and work with you there while I was working on energy efficiency in commercial facilities, primarily public facilities. So this summer, I made a transition to Bettisworth North. My firm was mentioned yesterday when John Paul was speaking. It's the Tanana Chiefs Conference Clinic that has won a lot of awards, and we're very proud of that project. My new role at Bettisworth North is called Energy Programs Manager. And basically what I'm trying to do is, when I was at HFC, I saw a lot of need for someone to kind of help clients figure out, I know that my utilities are too high, and I know that it's impacting what I can do with my budget, and how do I get them lower? There's so many programs, there's so many, I can get an audit, I can do benchmarking, I can do retro-commissioning, I can do all these different things, but I don't know what to do. And so what I really wanted to do was go out into the communities and work with clients specifically and help them make a path for themselves and for their projects. So, some of the things that I do is I help clients set energy performance goals. Do they want to meet LEED? Do they just want to lower their operating costs? Those kind of things. We can work with you to help you get grants and to know which grant and which program works for which of your facilities. We can help you find grants and apply for those and then actually do the projects. One of the main things that we're really pushing is energy management services. So that's just kind of looking at where you're at. Do you need benchmarking services? Do you need to do some retro-commissioning? Where are you at in your energy management goals, and how can we help you reduce your energy use and cost? We also work heavily on operations and maintenance. I worked with Karen Johnson at the Denali Commission a lot when I was at AHSC on understanding the connection between, you can have a really great design, but if it's not operated properly, it's not going to run efficiently, and vice versa. You can have amazing operators, but if the building's not set up to run efficiently, it's not going to achieve what you need it to do, so it takes both. And so we really try to work with the operators, and that's part of that energy management ongoing services of helping you try to get training for the operators and make sure that things are really running as well as they can. So anyway, I think to my knowledge, we're the only architectural firm in the state offering these services. If you have any questions, please let me know, and thank you.
Wow, right down to the zero, perfect. So they must be very precise in their work is all I can say.
Yeah.
So the Westmark has given us 2 gift certificates. This first one we're going to give away is lunch for 2. It's the value of $25. And I have it here. Who's it going to, Gwen?
Jason McEvers with Capstone Solutions.
Well, there you go. Okay, so let's queue up. We have the George and Richard show.
So, Rich, you're first. Rich Weiss.
Okay, I'm Rich Weiss. I'm a professor of electrical engineering up at the University of Alaska Fairbanks. I do a lot of work in energy efficiency and also in isolated grids like you find in the rural communities of Alaska. I have the impossible task of being a professor and trying to plead my case in less than 3 minutes. Who in the room is from a coastal community? Okay, so very good number. Some of the coastal communities have fish processing facilities. I'm going to talk about a project that we were involved in starting in 2010 that was funded through the Alaska Energy Authority. And that project involved looking at these plants and both from an electrical and a thermal perspective and seeing how efficient they're operating. So we sampled 8 plants. George is going to follow up after me, and they're continuing some of that work. But the idea was to look at things like motors, variable speed drives that drive those motor processes, and to see if they're operating efficiently. What we found in general, I'm not making any specific names or bringing out any specific companies, is that in general the plants were operating inefficiently electrically in terms of the fact that they have old technology. And so what we did then is we did an analysis to figure out, okay, if you were to go in and replace this system with a modern, more efficient system, what would be the cost improvement? What we found in a nutshell is that, yes, there would be a cost improvement. However, payback is long, 10 years, 12 years, 15 years. So we also looked at refrigeration systems. What we found with refrigeration systems is that many of the plants had already gone through and gotten money to, or had their corporations give money to actually upgrade those refrigeration systems to modern technology so that they could more efficiently heat, more efficiently cool their refrigeration rooms and their capabilities. We also did some work with thermal analysis of the actual freezer containers, cold storage, as well as flash freezers, plate freezers and such. And what we found out is that a lot of the fish processors had older facilities and they were poorly insulated, and so there was a lot of leakage. And so there was benefits to simply doing things like taking old butcher block freezer doors and replacing them with modern doors that actually had really good.
That's probably.
Let me just get this straight. So, Rich, so George is going to talk about part B of this project. So it would take two professors at the university to come up with a loophole in our system here.
Well, and I just want to know, do you learn that technique from your students, or that's you've heard all the creative excuses
All right.
possible?
Can you go ahead and draw
yeah,
one?
we need you to draw not from that.
I think we need to set some better
yeah.
ground rules next time.
Okay, so Gwen, who's this bag
If you
going
draw
to?
your own name, then I know we're really in trouble. Okay.
I didn't.
Daniel Jimmy from Kipnuk.
Where's Daniel? We'll see if he shows up by the end of the.
All right.
He might be in the.
If anyone sees him, send him our way.
Okay, if not, we'll send it off at the end.
Okay. George,
Mr. Rowe, your 3 minutes.
maybe we should give him 2.
That's my boss talking. Okay, so my name is George Rowe. I'm a research professor at the University of Alaska Fairbanks. What I'd like to talk about is an opportunity that some of you may be able to engage in downstream. The Department of Energy has a program called the Industrial Assessment Centers, where they'll deploy teams of students and faculty to come at no charge to facilities that are in certain manufacturing categories, which includes seafood processors, but also includes sawmills, metalworking, shipbuilding, etc., to do assessments in terms of short-term payback opportunities for energy, water, and process flow. We had the opportunity of checking out this approach in Kodiak. We went to 3 different seafood processors. We had a team of 9 people. We had 4 students from Idaho, a faculty member from Idaho, and then 2 students from here, myself, and a research technician from up here. And we had a great opportunity watching as we went from seafood processor to seafood processor, one each day, how the students grew in their understanding of what the technology really looked like, from the block diagrams that they'd seen in their textbooks earlier in their career to the actual systems that are out there. And so we're very curious to see what the general interest is in terms of how this could be implemented in Alaska and what the things should be done to tailor that to make sure it really is Alaska relevant. One thing that we can tell you is that the database that's available for evaluating these returns of investment doesn't have Alaska-specific transportation costs incorporated. So that is already something that we're already dialoguing with the Department of Energy on enhancing. It's also identified, just in this short visit, some training opportunities where refrigeration technicians may be able to operate their systems more efficiently through some fairly simple procedures. Rich talked about some of the insulation, etc., but there are some things that operationally, water and ammonia, etc., that some people weren't aware of what the impact was on their system operation. And it seems like these capabilities could be very interesting to implement. So my contact data is available. I would love to talk to you if you'd like to pursue this further. Thank you.
Well done, sir. Well done.
Can you draw a name for us?
So we'll give away another bag here. And is Gary ready? We'll have you next. And what about Tracy? Okay, good. And you got your slide loaded up? We're good.
Mike Miller from Brown University.
Mike? Hey, here we go. Excellent.
I don't think it doesn't seem to be, so.
Okay, good afternoon. My name is Gary Hennig, City Manager for the City of King Cove for the last 25 years. We want to tell you about one hydro that we have and another hydro that we soon hope to build. King Cove is like way out remote rural Alaska, 625 miles southwest of Anchorage at the end of the Alaska Peninsula. We sometimes feel like we're the Rodney Dangerfield of renewable energy, and part of that simply because we haven't maybe told our story enough. We also think that maybe the old Panasonic ad that we're slightly ahead of our time is catching up with us, and we're okay with that. But 1994, we didn't have a hydro, all diesel. A little bit over 3 megawatts of power a year we would generate at 60 cents a gallon and at 20 cents a kilowatt hour. Back then, that was a great price. Even in today's world of all the PCE family members, that's still good. Anyhow, Delaware Creek Hydro happens in 1995. 20 years later, our demand, because the community's been growing, is slightly less than 5 megawatts. 60% of our power today is from the Delta Creek Hydro. The cost of fuel has gone up to $4, a 700% increase. Our cost of a kilowatt hour of electricity is still just 30 cents. I know when I say cheap, it's a relative term, but to those of us that are in the PCE family, 30 cents a kilowatt hour is at the low end of the group. So where we're excited is we have another hydro that is 100% construction bid ready, going to bid in 2 months. It's a $6 million project. We have some amount of AEA funding already. We're hoping for more, and that's not too subtle of a hint that, you know, we're hoping for more. But one way or another, we're going to build that, and by the summer of 2016, little old King Cove, Alaska will have 75% of its annual power coming from renewable energy, and that is just freaking outstanding for rural, remote Alaska. So that's my story, and you'll hear more about it later. Thanks.
Excellent. Way to go.
Would you draw a name for us, please? Peter Miller from Tentatuliak.
Is Peter here? Okay, we'll do one more call for Peter and Daniel at the end. Set that aside. And, okay, Tracy is up next. And then we've got Karen Johnson.
I need to load my PowerPoint.
Oh, you can go next. Sorry, I just crossed out there.
Oh, okay, good. Multi-azimuth. Here we are.
Yeah, we could draw another name while he's messing with the technology. Or is he ready?
We're ready.
He's
I'm ready.
Okay, go.
Okay, my name's Tracy Dahl, and I work in support of the National Science Foundation's Arctic program. And I'm not really selling anything other than perhaps a concept. So I want to talk about multi-azimuth PV arrays. This one is actually in Greenland at the top of the ice cap. And the idea was to basically do both research but also have a practical application. So it's a 3-sided tower that is grid tied. One of the interesting things is looking at the actual energy production. Here we're looking at the south array and the east array, or northeast really. And you can see that the power production is surprisingly good, about 66% of what the south array did. Better yet is the northwest facing array, which actually produced 83% of what the south array did. And the point is that the higher you go in latitude, the more these even out. If it was at 90 degrees north or south, they would be identical. The reason that the east array produced slightly less is because of local meteorological conditions, basically some morning fog attenuating the solar. The tower itself is kind of cool. It uses the PV panels for structural members. And so here we're looking up from the bottom. It's a tilt-up style tower. Myself and one other guy built it at the top of the Greenland ice cap in a week using hand tools. Now we're switching over to Alaska, another type of multi-azimuth array. This one more tuned towards the tundra environment. So in the A-frame, you basically see east and west facing panels, and then the one on the right side of the screen is pretty much a conventional south facing array. And this is for a direct science support project that had a relatively high power requirement, about 500 watts continuous, which doesn't sound like a lot, but continuously 24 hours a day, it's a fair bit. So there's just a photo putting it together. It did have a backup generator on it, but it did not have to run at all during the course of the summer season. Just a shot of the power electronics box. Each of the PV arrays, of course, has to run to a separate charge controller. Yep, just a little detail. So another point to make is that you can use the panels themselves as a structure of sorts. So, yep, there it is.
There it is. All right. Thank you very much. So, why don't you grab two lucky winners, and David's going to go next.
Tim Barnum
There's Tim.
with McGrath Light and Power. Bernadette Fisher with the North Slope Borough. We're getting good regional diversity in our selections here. That's nice.
Indeed. Okay, is Bernadette still here? Or we'll do a last call and draw more names if we don't get them.
Do you have a presentation? I do not.
He doesn't, but
Okay, so I'm assuming you're going to start the time when I start talking. I'm David Nickel. I work in Alaska I'm a third generation fisherman in Bristol Bay. When I'm not fishing, I'm working for Capstone Solutions doing solar plant development. And so you can find me in Naknek in October because we're going to be there installing an 80 kilowatt solar installation for the school in Naknek, the Bristol Bay Borough School District. This is costing them no money. We're doing this as an IPP project. We're capturing the tax credits and then we're selling them power for about 40% less than what they can currently buy the power for. We're only putting a 3% riser on that cost of power, and currently they're historically paying a 10% riser. So this installation will cost them, will save them about $20,000 a year. And if we can work out some issues with the utility or find another off-taker, we're going to go back in the spring and put on another 100 kilowatts. We're hoping to save them about $50,000 a year. That's our goal. With $50,000 a year, they can bring back a teacher they just had to lay off. So solar is totally feasible in Alaska. Yes, there are some technical challenges with interconnection, but the technical challenges can certainly be overcome. They're really not that complicated in the end. And I can tell you that with Capstone, we also do a lot of telecommunications solar. We're pretty experienced at tying in diesel generators, battery systems, and solar arrays. So it's been done before. There's no reason that Alaska has to reinvent the wheel to overcome these problems.
All right. Thank you very much.
Thanks.
And
Can you draw for us?
why don't we do another two?
Two more. Take two. Esther Lincoln, White Mountain Utilities. Whoops. And Grace Villarreal from Huna.
From Huna, IPEC. Okay, Karen, take it away.
Hey everyone, my name is Karen Johnson. I am with the Denali Commission. I've been there since 2007, and my specialty area is workforce development. So we take a look at all these complicated systems that are brought out to rural areas and left for the rural residents to maintain and operate. And so with this project that I'm going to talk about today, it's called the Rural Alaska Maintenance Partnership. And it's also known as RAMP. What we wanted out of this project was to build the capacity of local workers to be on hand, on demand, to be able to maintain these new buildings, new systems for the long term. So this idea actually was budded at the Rural Energy Conference in 2011 with my friend Dina Straight and Scott Waterman in a side meeting. We're like, we have all of these investments, we need to we need to protect them, and so we started talking about ways that we could do that. Well, we brought together a bunch of high-level individuals that had this same thing in mind. We created a mission right away. The mission is to create a self-sustaining facility maintenance operation and maintenance system that develops the capacity of rural Alaskans to operate and maintain their own infrastructure in a manner that protects and enhances the health, safety, and sustainability of rural communities and their residents. So we're talking about all facilities in a community: fuel tank, farms, water plants, clinics, schools, stores, post office, private homes, canneries, you name it. The goal is twofold. One being an economic side of it, to build a local or regional facility maintenance service or business that has the capacity to maintain all public and private facilities, creating jobs, on-hand and on-demand workers. The second part of it, in order to make that part successful, building this local capacity or creating these jobs, is to have a training system in place that trains these local workers. So we worked with the regional training centers and the universities on this, and it was really what we came out with was to build or develop a state-recognized certification for facility maintenance workers, which we have. 4 centers of excellence rose to the top. We have UT in Bethel, Bristol Bay campus in Dillingham, AvTech in Seward, and Interior Solutions campus here in Fairbanks that are now offering level 1 facilities.
Thank you, Karen. So if you'll draw the last 2 bags here, and then after...
Karen, you're going to be around at the Denali Commission booth if people have questions about the program, so they can come and talk to you more about it? Okay. Here, can you go ahead and draw a couple for us?
Sure.
2.
And then after this is going...
We actually have a 3rd bag there. I think I stole it, or I tried to.
Oh,
Gwen.
Johnson, no kidding.
Mark Bryan from AVAC, Alaska Village Electric Cooperative.
Dina?
And Leah Boltz from Bettisworth North. Yeah.
There you
Thank
go.
you. Thanks, Karen.
Okay, Leah. And then we've got 3 other big prizes after the last speaker, which happens to be Gwen Holdman.
All right. Well,
Start the clock.
That's right. So, no, as many of you know, I'm the director of the Alaska Center for Energy and Power. We're an applied energy research program based at the University of Alaska Fairbanks. We're very focused on the challenge of delivering affordable energy to Alaska's communities, to our businesses, to our residents in the state. I just want to quickly ask everyone that's affiliated with ASEP to raise their hand. We've got really great group of researchers at the university, and I hope that many of you have had the chance to interact with them during this conference. We've been involved in partnering with the Alaska Energy Authority for the last few years in putting on this conference. I've really appreciated the collaboration that we have with them, but that's not what I want to talk about. We are part of the Institute of Northern Engineering, which actually has 5 centers, of which ASEP is one. The others are the Water and Environmental Research Center, the Petroleum Development Lab, the Mineral Industry Research Lab, and the Alaska University Transportation Center. There are a lot of researchers doing great research on problems that are relevant to rural Alaska, all kinds of different projects and problems, and we are having a Solutions Summit at the BP Energy Center next week on September 30th, and I've got some invitations here. So especially those of you that are based in Anchorage, working in this industry, working on rural projects, period, not just energy projects, I'd encourage you to come and get a hold of me. I'll have these flyers at the ASEP desk at the registration center. We'd love to have you join us. It's going to be a pretty small group, but just to learn a little bit more about the capacity within the College of Engineering and Mines and Institute of Northern Engineering at UAF.
Huh, look at that.
Look at that, no problem.